Let us discuss one small example related to supermesh. Uh, Supermesh is a concept where it is going to form when two meshes have common current source. That means dependent or independent. Like say for example, this is a circuit where we have a common current source. Like here you can see this particular, these are total three meshes, and in between these two there is one current source. Now in this situation we have to apply concept of super mesh. uh, Normal procedure is just first of all we have to identify how many total meshes are there. Then you can assume the mesh currents as per our conventional practice, and then if super mesh found, then we have to write KVL equation for that super mesh, and then we can solve as per our regular practice. So here our problem statement is we want to find out current flowing through 5 ohm resistor. So this particular resistor we want to find out the current, and this is the situation where between these two meshes or loops there is current source appearing. So current source exists and it cannot be transformed into voltage source because there is one series resistance with the current source, and therefore we have to consider some other approach, and that is nothing but the super mesh. So here mesh 2 and mesh 3, this is going to form a super mesh. This dotted loop as a whole loop is going to form, and in this loop the current flowing will be I2 minus I3. That is, I2 is in this direction and I3 is like this. So I2 is this clockwise, I3 is also clockwise in the loop, within the loop, but when it is coming or appearing here, then its direction is opposite to I2. So one is in from left to right, another one is from left to right, and this one is from right to left. So therefore we are assuming this as direction I2 minus I3 is nothing but 2 ampere current. So this is our actual super mesh equation, KVL after applying KVL. So we can just simplify as our regular practice for loop 1. So it is in loop 1 you can see this 10 and 5, both of them are carrying like I2 minus I1 in 10 plus 5 I1, because both of them resistors are carrying I1, and this 10 will also carry I2. So that is 10 minus 10 I2. Otherwise, we can write it as 10 into bracket I1 minus I2, and then 5 into bracket I1 minus I2. So therefore, both of them are carrying 10 plus 5, that is I1 minus 10 I2. And for 5, it is 5 I3. So for 5, I1 and I3, and for 10, I1 and I2. So here it is I1 minus I2 into 10, and here it is I1 minus I3 into 10. Therefore, this minus 10 I2 minus 5 I3 and this 50. So this way if we write, otherwise you can start with 50, then 50 minus 10 into bracket I1 minus I2 minus 5 into bracket I1 minus I3. And therefore you can just change the directions, and you can write the equation like this. So this is our, in the simplified form, 15 I1 minus 10 I2 minus 5 I3 is equal to 50. And for second and third mesh, ignoring that branch, this will appear like this, and this whole loop we will write the equation, drop across 10, drop across 2, drop across 1, and drop across 5. So the terms will be 10 into bracket I2 minus I1. Here I2 and I1 sharing. Here only I2. Here only I3. And here again I1 and I3. So there are total 4 terms. 10 into bracket I2 minus I1. Then 2I2 plus I3. This I3 is through this 1 ohm. And 1 into I3, that is I3. And plus 5 into bracket I3 minus I1. Is equal to 0. So this whole equation we have written. Now this is coming out to be 15I1 plus 12I2 plus 6I3. And now let us use our simultaneous equation solution technique using matrix. So this will be first column corresponding to this first equation. So here I1 term is not present, so therefore 0. And second one I2 and I3 we have written. So then next one, 1 minus 10 and 12. So this is 1, then this is minus 10, and then 12. For first equation, since I1 is 0, so therefore 0, 15 and minus 15. And second one, 1, then minus 10, and plus 12, and the third one is minus 1, minus 5 and 6. So minus 1, minus 5 and 6, and I1, I2, I3, and right side your constants. So here it is 2, then here it is 50, and this third one is 0. Therefore 2, 50 and 0. Now first of all let us calculate a delta. So 0 into bracket minus 10 into 6 minus minus 5 into 12 minus 1 middle column plus minus like that, alternately sign change you have to do. So 1, and then here we can take clockwise. This is minus 1 clockwise, 15 into 6 minus minus 15 into minus 5. This is second term, and then third term is no sign change, minus 1 into bracket 15 into 12 minus 15 into minus 10. So if we simplify this, this is coming out to be minus 45. Now since for current through 5 ohm, we need to calculate I1 and I3. You can see here through 5 ohm, I1 and I3 is flowing. So therefore, let us have first of all I1 calculation. So therefore delta 1 when we calculate, then we replace this first column of I1 by this constants 250. So here we will write and simplify the determinant 250, and now 2 into this minus 10 into 6 minus minus 5 into 12. So that is minus 60 minus 60 minus minus plus 60. Second term will be minus 1 into bracket 50 into 6 minus 0 into minus 5. So 300 minus 0. Third term no sign change, minus 1 into bracket 50 into 12 minus 0 into minus 10, it is 600 minus 0. So it is coming out to be 900. So minus 900 divided by minus 45, that is delta 1 divided by delta Z, it is coming out to be 20 ampere. Same fashion for I3, you can calculate delta 3, and then same way delta 3 divided by delta Z will give you my 15.33 as I3 current, and therefore current through 5 ohm resistor is I1 minus I3 is equal to 20 minus 15.33, that is 4.67 ampere. So remember, in super mesh what we have to do is, wherever this mesh we are considering, that is the loops considering, in between if there is a current source which cannot be transformed into voltage source, if it is having series resistance, then you have to apply concept of super mesh, and for that particular branch you can write a super mesh equation like this, and then rest of the procedure, the two loops which are actually sharing that particular branch containing current source, that those two loops are going to form a common loop that will be treated as a or a common mesh, that is will be treated as a super mesh. Okay.